All right. So you can open the BigMart sales data preprocessing file where we have done the preprocessing and hypothesis testing. Run all cells. Now, so supervised learning broadly has two categories: regression models and classification models. Regression models and classification models are the two broad categorizations within the supervised learning. Now, how to decide which model to run? Now, it all depends on the dependent variable. The dependent variable denoted by Y is numerical, continuous, closer to normal distribution, with minimum outliers and no missing values, then regression models are run. The structure of the dependent variable will decide whether to run a regression model or to run a classification model. The structure of the dependent variable, which is denoted by small y. If the dependent variable is numerical, continuous, closer to normal distribution, with minimum outliers and no missing values, then regression models are run. Dependent variable denoted by small y is non-numerical and categorical, either binary, when I say binary, yes or no, or multinomial. Multinomial means more than 2 levels. Classification models are run. Classification models are run. So the structure of the dependent variable, will guide us. No, this one. Huh? The structure of the dependent variable will decide whether to run a regression model or a classification model. Right? Now, what is the dependent variable? What is the dependent variable in BigMart sales? The dependent variable is item outlet sales. For us, the dependent variable is item outlet sales. Right? Sigma trained here dot item outlet sales dot plot kind is equal to box comma what is equal to false. So Bigmart says the dependent variable is numerical, continuous, not closer to normal distribution, there are outliers. Okay. So for Bigmart train data, what type of models we should run? No, regression models. No, the data is numerical and continuous. Sales. How is sales data? Numerical, continuous, right? It's a numerical data. Even then, you have to run, it's a numerical data. It's not non-numerical. Non-numerical means is underscore component 0 and 1, which is yes or no. That is non-numerical data. Here it is purely numerical data. We have to run regression models. So for Bigmart sales, we have to run the regression model. See, you cannot create box plot for non-numeric data. You cannot create box plot for non-numeric data. You cannot create histogram for non-numeric data. You cannot create density curve for non-numeric data. Right? When you are using these three graphs, that means the data, the dependent variable is numerical and continuous. Classification is different, regression is different. Name is there, but it's completely different process. So within regression, the primary model is multiple linear regression. Multiple linear regression is the primary model within the regression algorithms. Within the regression algorithms, multiple linear regression is the primary model, often referred to as MLR. MLR explains the linear relationship between a dependent variable denoted by Y and multiple independent variables denoted by capital X. Multiple linear regression explains the linear relationship between a dependent variable Y and multiple independent variables X. So the multiple linear regression is an equation. MLR is an equation. The output of the model is an equation. The equation looks like this. Y is equal to B0 plus B1 x1 plus B2 x2 plus B3 x3 plus B4 x4 till Bn xn plus Et. This is the linear regression equation. Multiple linear regression equation. Y is equal to beta 1 plus beta 1 x1 plus beta 2 x2 till beta n xn plus b delta or Et. This is the equation of a multiple linear regression. Y represents dependent variable. Y represents dependent variable. B0 represents intercept or constant. What is an intercept? The point at which straight line touches the y-axis. Intercept is the point at which the straight line touches or breaches the y-axis. That is called intercept or constant. B1, B2, B3, B4 till Bn, we call them as coefficients. We call them as coefficients. X1, X2, X3, X4 till Xn, we call them as independent variables. Independent variables. ET is called error term or also called as residual. Residual, the formula is actual value minus predicted value. So this is the equation. Y is equal to intercept plus beta 1 x1 plus beta 2 x2 till beta n xn plus the error term. Y is the dependent variable. B0 is your intercept or constant, which is the point at which the straight line touches the y-axis. B1, B2, B3, B4, all Bn's are your coefficients. X1, X2 are your independent variables, and then the ET or error term, also called as residual. The formula of residual is actual minus predicted value. This is the equation explanation. The output of regression is equation. The output of the regression is equation of this nature. Huh? No, we have just started with the notes only. After chi-square test. We have done the chi-square test, no? After chi-square test, we are starting with the notes. Okay. All right. Now, the assumptions. Assumptions of multiple linear regression. Dependent variable denoted by y must be numerical, continuous, closer to normal distribution, with minimum outliers and no missing values. No missing values. This is the first assumption. The first assumption is the dependent variable must be numerical and continuous. Second, independent variables denoted by capital X can be both numerical and non-numerical. Independent variables can be both numerical and non-numerical. The third assumption, linearity assumption. There must be a logical linear relationship between the dependent variable and independent variables. Assumption of linearity. There must be a logical linear relationship between the dependent variable and independent variables. A logical linear relationship must be there. That is the first assumption. Third assumption. Fourth assumption, multicollinearity. Multicollinearity. No multicollinearity. No multicollinearity. Multicollinearity means very strong correlation. Very strong correlation, typically greater than 0.95 between among variables. Two variables having correlation greater than 0.95, then we can say that both variables are multicollinear. If multicollinearity is found, do not include both variables. Do not include both variables. Choose one among them. Choose one among them, else overfitting problem will occur. Multicollinearity. Multicollinearity means a very strong correlation greater than 0.95 between two variables. If you find multicollinearity between two variables, you should not include both the variables in your model. You have to choose only one variable among them. So before running multiple linear regression, you must run correlation analysis on numerical data to identify multicollinearity. Now, there is another method. We have something called variance inflation factor. Variance inflation factor, also called as VIF. VIF greater than 2 indicates multicollinearity. The other measure to find multicollinearity, which we don't get in R and Python, which we get in other statistical softwares like SPSS and SAS, is VIF, variance inflation factor. If the VIF is greater than 2, it indicates multicollinearity. So multicollinearity can be checked with two, either doing correlation analysis or calculating VIF. In both R and Python, we do correlation analysis, which is there. VIF is a separate library and package. They are not in the base model, so we will avoid VIF. So correlation to identify multicollinearity. If multicollinearity is found, do not include both variables. You will include only one variable among them. Otherwise, it will lead to overfitting problem. 5. Exogeneity. Exogeneity is an assumption that dependent variable is dependent on independent variables, but independent variables do not depend on dependent variable. Exogeneity. Dependent variable is affected by the independent variables, but independent variables are not affected by the dependent variable. Or simply saying, y is dependent on x's, but x's do not depend on y. Exogeneity. Exogeneity means dependent variable will dependent on the independent variables, but not vice versa. That we call it as exogeneity. 6th, the sample size required is minimum 20 observations per variable. The minimum sample size required is 20 observations per variable. Now we have some assumptions on residual or post model. We have some assumptions related to residuals, which is post model. Seventh assumption, residuals must be homoscedastic. So residuals must be homoscedastic in nature. Homoscedasticity is one of the residual assumptions which we need to follow. Homoscedasticity and heteroscedasticity. When you plot this scatter plot of residuals, if the residuals look like this, all of them in closer range, narrow range, left to right, upward, we call it as homoscedastic in nature. It is a satisfactory model. If the residuals are spread like a flower bouquet, we call it as heteroscedasticity, or it is not a good fit model. Homoscedasticity of residuals is one of the assumptions of regression. In regression, the homoscedasticity is required. If the residuals, the moment you plot a scatter plot of residuals, if they look like this, then we call it as homoscedastic, and we say it is a satisfactory model. If they look like this, it is an unsatisfactory model. The eighth assumption is residuals must be normally distributed. Residuals must be normally distributed. Now, for normal distribution of residuals, we do something called QQ plot. QQ plot, quantile plots, will tell you whether the model is normal or not. If you see that all the residuals plotted on a line like this, we call it as a normally distributed residuals. If the observations are moving away from the line, we call it as a unsatisfactory model. Normal distribution of residuals is mandatory. All the observations must be engulfing the line. If they are moving far away from the line, if too many observations are moving from the far away from the line, then we call it as a non-normal distribution. It's not a normal distribution. We call it as a failed model. So residuals must be normally distributed. This is post model. Now you will get these plots in R because it's a statistical software. You won't get these plots in Python because Python is a more machine learning oriented language. So, but we can still plot them in R and in Python also, and we can check the values. Okay. So these are the assumptions, 8 assumptions of multiple linear regression. These are the 8 assumptions of multiple linear regression. 6 are pre-model, 2 are post-model. After building the model, 2 assumptions. All right. you look at this equation, what data we have? So y and x's are what we don't have, the intercept and the coefficient. The multiple linear regression algorithm will solve for the intercept and the coefficients. It's a the mathematical formulation or the matrix formulation is this: x transpose multiplied by x to the inverse matrix multiplied by x transpose multiplied by y. X transpose multiplied by x to the inverse of the matrix multiplied by x transpose multiplied by y. If you solve this matrix formulation, you will get the coefficients and the. If you want to code the algorithm, you have to code this formula. X transpose multiplied by x to the inverse matrix multiplied by x transpose multiplied by y. This is the, if you want to code the algorithm, you have to code this formula. Once you solve this matrix, you will get intercept and the coefficients. So this is inverse matrix multiplied by x transpose multiplied by y. That is the matrix formulation of multiple linear regression. Same process is used in R, Python, or any software where the backend it converts the independent variables into a matrix, transposes the matrix, calculates the multiplication of this with the inverse matrix. Same procedure is done backend by R, Python, SPSS, SAS, or any other software. So the matrix formulation is this. The matrix formulation. The matrix formulation of multiple linear regression is B0, B1, B2, B3 till Bn is equal to x transpose multiplied by x to the inverse matrix multiplied by x transpose multiplied by y. So in this equation, this is transpose of x. This is inverse matrix of multiplication of x transpose and x. Okay, this is the matrix formulation of multiple linear regression. This is the mathematical calculation behind the multiple linear regression. Once you get the intercept and the coefficients, you can calculate by multiplying the intercept and coefficients with the independent variable matrix, you can calculate predicted y. Once you get the intercept and coefficients, you multiply the intercept and coefficients with the independent variables matrix, you will get predicted y. From that, actual y minus predicted y, you get the residuals. Actual y minus predicted y, you will get your residuals. From residuals, we calculate sum square residual, sum square reading, mean square error, R squared. So everything starts from the calculation of the residuals. But before that, we need to solve for the intercept and the coefficient. In statistics, you get a larger output. In Python, we get very smaller output. So the interpretation of output. The interpretation of output in Python only. I'm not talking about the statistical interpretation. As I run the model in R, I will talk about the statistical interpretation. But as of now, I will only talk about the whatever output we are going to get in Python. The first, you will get R square. R square must be between 0.60 to 0.95. R square. What is this R square? R square explains the amount of variance occurring in dependent variable, amount of variance occurring in dependent variable y caused by the independent variables denoted by x. The interpretation of R square. Amount of variance occurring in the dependent variable caused by the independent variables. The value of R square must be between 0.60 to 0.95. If it is less than 0.065, 0.60, it is a failed model, or we call it as an underfitted model. If it is greater than 0.95, we call it as a overfitting model. This is the range. The second we will get is the intercept and coefficients. You will get the intercept plus coefficients from which regression equation is created for predicting the dependent variable y. So in Python, we get R square, we get the intercept plus coefficients. Only two parameters, we get it in Python. Now, the diagnostics for all regression models, the diagnostic for all regression models is root mean square error, also called as RMSE. RMSE is the diagnostic for all regression model. There is no fixed value, lower the better. It is a comparative metric. It is a comparative metric. Lower the better. The formula is RMSE is equal to sum of, square root of sum of actual value minus predicted value to the power of 2 divided by n minus 1. This is the value. Square root of y minus y whole square. RMSE sigma y minus y hat whole square divided by n minus 1. Y is the actual value, y is the predicted value. RMSE is the diagnostic for the model. It is a comparative metric. There is no fixed range. Lower the better. Lower the RMSE, the better. So these are the assumptions, the equation, and the theoretical background of multiple linear regression, which you must know is one of the common question interviews. What is MLR? Explains the linear relationship between a dependent variable and multiple independent variables. The equation, the assumptions, multicollinearity, linearity, exogeneity, sample size, residuals must be homoscedastic, residuals must be normally distributed, and the matrix formulation, X transpose multiplied by X to the inverse matrix, multiplied by X transpose multiplied by Y. Then the interpretation, you get the R square, that should be between 0.60 to 0.95, which explains the amount of variance happening in the dependent variable caused by the model. Then you will get the intercept and coefficients for creating the regression equation. And finally, for the checking the effectiveness of the model, we calculate RMSE. Root mean square is the diagnostic for all regression models. You compare RMSE of one model with other model. It can be a same model of linear regression with two different set of variables, or it can be intermodel like regression with decision tree or random forest or boosting machine or any other model. Okay. So we have done our label encoding and all the processes, right? Bigmart train DF dot columns. All right. Now we will split data into dependent variable y and independent variables x. Y is equal to Bigmart train dot item outlet sales. X is equal to Bigmart train DF. X is equal to Bigmart train DF. Small y represents dependent variable. Capital X represents independent variables. It's not there, no? It is already removed. Do we have outlet sales in X? I don't think we have outlet sales in X. Check the columns. Okay, okay. But I didn't see it. Okay. Dot drop item underscore outlet underscore sales comma access is equal to 1. Then we'll take this as the Bigmart train DF dot item outlet sales. Got it, all of you? Y index from sklearn dot linear underscore model import linear regression. Reg is equal to linear regression. Reg model is equal to reg dot fit x comma y. Reg model dot score x comma y. R square of 0.5637. Fit the first import the function, give a short name to the function, then fit the model, then score the model. Dot fit x comma y, dot score x comma y. Score will give you R square. Now is our R square correct? R square is telling us that the model is underfitting. Why it is underfitting? Because of the outliers in our data. We have a lot of outliers in our data. That is why it is underfitting. Why do we have outliers in our data? Because some stores will perform very well, some stores will perform very, very bad. So for that purpose, so the R square is 0.5. Very important. I are not able to check. Where is the old notebook? I am getting a new notebook. Where you go? Change the data format. That is, you say the folder is not there. There is the folder. Save the path somewhere or text file. Run all the cells. What is it giving us? Right? What is the minimum threshold? 0.60, right? Why is it not giving? Less than 0.60. Why is it going? Because of the outliers problem. Because we have changes in outliers problem, right? Skewness. outliers, skewness, and kurtosis in variables, both dependent and independent, are the reasons for underfitting. The common reasons for the model underfitting is outliers, skewness, and kurtosis. Or if the data is not closer to normal distribution. If the data is not closer to normal distribution, we have this problem. Eric? After getting there are brackets, right? Without having brackets, how will the positional arguments? For this data, we can't do anything. We have to go for the next level of models. Models that are resistant to outliers, models that are resistant to skewness. Which are the best ones? Resistant to random forest, similar networks. They work with outliers, they are resistant to skewness, they are advanced models. This is a basic model. Very, very basic model is linear regression. It is highly sensitive to outliers. It is highly sensitive to skewness. But advanced algorithms like decision tree, random forest, neural networks, boosting machines, they are not sensitive to outliers and sort of spin form. Spin means what? Your data still has text. It's dying. That is the problem. I told you now, well, one single string is there, it will never execute the model. So combined video three. See, combined video three is right and right. So why I is not converting? Run through the problems again and then again. Take that random comment something. Nobody comes to outside side and becomes a problem. All right, all of you got it? Now, see, we discussed that if there is positive skewness, we found out that there is positive skewness, right? In our dependent variable, there is positive skewness. What is the correction mechanism? Log, right? So I will run reg model 2 is equal to reg dot fit x comma np dot log of y. Hello. Yeah, tell me. Yeah, tell me. Ah, okay. Ah, okay. Okay. So what I would suggest is go to Bangalore for 3 months or 6 months, and then you start searching and you get out immediately. So see, you move to Bangalore, okay? You work with the Ola thing for 3 months or 4 months. You have to start right away putting your resume, but you'll gain good experience in SQL, right? Practice and SQL experience will gain in 2-3 months. That will be an additional experience for you. So then you can search for job again. Yes, yes, yes. Don't worry about that part. You will also practice in R and Python. Whenever there is a hackathon and anything on analytics, you participate. Keep yourself updated with R and Python. Right away, you put your resume again and start searching. No? Put your resume in LinkedIn jobs that you are employee of Capgemini and start finding a job which you like. See, that process will always happen. You might not like something, so but you still have to do it for some time, and then get out with a good offer. You can't initially say no. Outrightly, if you say no, then it is not good for your resume also. Okay. So you just go to Bangalore, stay there for 2-3 months. Not much of an inflation compared to Hyderabad. Bangalore and Hyderabad are similar. Okay. You go there, work for 2-3 months. If you don't like the job there, you talk to your manager and come back to Hyderabad. If not, then you start looking for a job. This 3-4 months experience will also count and you will get a good opportunity again. But you have to accept the offer and go. If you say directly no, then it will be not good for your resume. Okay, you just go there, you change of climate for you also, stay for 2-3 months, understand the job. You like it, you continue. Or else you immediately after 2-3 months, 2 months, you talk to your manager saying you want to come back with a family problem or something. Then they will, if they consider, okay, if they don't consider, then you can look for a job from outside. And you can easily find a job. Once you have experience, you can find job anyway. That's not a problem. Okay, but don't say no. You have to go with it. Sometimes, like I told you, not all problems require Python and R. You might also have to work for SQL for some time. Then, once you have gained some experience in SQL for 2-3 months, then you either ask for a team change with your manager, or you resign and come out and look for another job and then resign and come out. Okay, so don't say no outrightly because that will not be good in your resume. Okay. Okay, so go to the dollar client, understand what is the process and all, gain some knowledge. Once you gain knowledge for 2 months, 3 months, it's just a small time, right? Short time of period. You just stay there for 3-4 months and come back. If you don't like it, you talk to your manager saying that the profile is not good. If they're okay and change your profile, you can come back. Or else you start looking for a job immediately and then you'll get it. Meanwhile, you update your resume as an employee of Capgemini and start looking at jobs with all your skill sets. The one-page resume is there, no? There you have an experience and saying that you are working for Capgemini right now. And start for looking for jobs. See, Ola is good now. See, you will get a practical. See, you will be having a very good experience of Ola, what we call SQL. Very, very large queries you will write. You will have good experience of writing very big queries in SQL, and then based on that, you can also convert some of that work into R also. Okay, but go there and work. Otherwise, don't take a decision beforehand. All right. You go to Bangalore, work for 2-3 months. You have any problem, you need any help, you can call me, or you just find some solution there. Or if you don't like it, give it time for 2-3 months, and then you make a decision after 3 months. You tell your madam, tell your manager that you want to change profile, and ask them to change it because you want to come back to Hyderabad with family problem or something, you say, and they will definitely consider it for change. If they are not considering for change, you can again do a job search. Within 1 month or 2 months, you will get a job. That's not a problem. Okay, but you have to go. You have to go and you have to look at the job profile there also. Okay, yeah. np.log. File number game number might be mistake. Positive skewness is corrected by using logarithmic transformation. See how the logarithmic transformation had convert your underfitted model to a fitted model. See, understood, right? What was the root cause? The root cause you understood now. By simply correcting skewness and outlier skewness in the right, we have converted the model from an underfit model to a fit model. Right? Next one. Score. Red model dot score. Dot score x comma y. No, that is wrong. How come you got such a bad? It might take a dot script, right? Then we have dot script. Okay, where is the problem country? Problem 0.54. You get 0.54. That means you get about corrected something. Both box plot will show you both outliers and skewness. Now you want to see what transformation it has done. It moved the outliers to the other end. It moved the outliers to the other end, which is again a problematic, right? Your model is fitting, but if you look at the outliers problem, it still persists, right? It moved from the right to left. It fitted the model, but when you look at the outliers, it is giving you wrong. Here's the problem. So basically, in the regression, you have to go for advanced models. You will go for advanced models from same data, and you will see how the performance increases. I send it to So see, logarithmic transformation is not the right method because it is moving outside from right side to left side. It is filling the model, but internally it is not the best method. Reg predict is equal to reg model dot predict of x. Reg predict is equal to reg model dot predict of x. NP dot sqrt, NP dot mean, reg predict start 2. RMSE of 7.34. RMSE of 7.34. But still it is creating a problem. Yeah, I've sent the notebooks. PDF and the notebook. Why? Star 2 to the power of is star here. Python syntax. There is no inverted V. It is star 2 to the power of. You are squaring the residual, right? Y minus y hat whole square. What is reg predict y hat? Oh, sorry. I didn't calculate residual. That is why it's getting wrong. 1 second. Reg residual is equal to y minus reg predict. We calculate the residual is y minus y hat, right? Reg predict is y hat. Now np dot sqrt, np dot mean, reg residual start 2. The actual is 2763. That's what I thought. Why it is coming so less? The root mean square error. So here we are doing the predict or y hat. Here we are calculating the residual, which is y minus y hat. Here we are calculating RMSE, root mean square error. So residual 2 is equal to reg model predict, reg model 2 dot predict x. Change it to reg predict 2. Reg predict 2. Then reg model 2 dot predict x. Then reg residual 2. Y minus reg predict 2. Then calculate the RMSE to check whether it is lower or higher. This is for the first model, non-logarithmic transform model. So, case na path change this company. We find out to path. Input I have path. Copy your code. Remove double quotes also. Copy. Double quotes is manifest. Nothing. Zero 0.53, right? Right predict to how did we get? Okay, we'll convert right predict to here only. See, RMS is lower. What is RMS is not 1140. PD first. PD now requirement for video coming. You change the name of the destination. So you have to start from here. Guys, remove my last residual calculation. Start from here. Predict model.predict x. Predict x is there, no? Then this one. Let's start from here. I'll have to remove the last line in my notebook. 7.63 got that will delete and calculate from here. Regression. The process of regression, you understood, right? So don't worry, this is the first attempt. We will do multiple things. We will get extra time. And biggest lesson, guys, focus on the needs. Focus on what we are doing. If you make one error anywhere, it will carry forward the whole process, and backtracking is very, very difficult. Okay? So please be careful about the spelling. That's why we will use the task function, autofitting and all. One mistake will completely make your regression model fail. And once it fails, you can't do anything. Okay? Lower best, which is lowest, that is the best fit. See, there is always 95% confidence level. There is no 100% in statistics.
For example, 96%, 97%, 0.95%.
You take to do it on test data, it will definitely be less than 90. You implement it again, do it again. If it stays there, then it's okay. For the multiple models, you get 95, 94, it is okay. But if there is a drastic change, then it becomes an overfitting problem. One second, I'll tell you. We got an R square of on reg model 2, how much we got? Reg model 2, we got 0.72, right? See, cross validation we did 5 times. I tested the same model 5 times. We got all the R square very close to one another. Right. But if it is changing, let us say one of the R square is some model is 64, 65, 62, then that is called overfitting problem. Drastic change in the train model score and the test model score. This process we call it as cross validation. Cross validation is repeated testing of data, repeated testing of the model with subsets of same data. It will create subsamples of the same data, 65% randomly selected rows. It will create subsets of 5 subsets of the same data and test the model 5 times. So here, CV is equal to 5 means 5 subsets of randomly selected data and repeated and 5 times testing of the model. 5 times testing of the model, and each time you got R squares as below. 0.72, 0.71, 0.70, 0.71 and 0.74. Repeated testing of the model. We call it as cross validation. If you get a model like this, then we call it as a stable model. If there is too much of frequency, too much of change, then we call it as a overfitting. Here, if you look at the NP log model, it's very constant, right? The difference is very, very small. So this is considered as a stable model. Cross validation is repeated testing of the model with different subsets of randomly selected data from the original data. So it will create 5 subsets of data from your X, randomly selected rows, 65%, and uses the data for testing the model. Right? And it finds the R square to be 0.72, 0.71, 0.70, 74, 75. Not much change. Very, very close to one another. So this is considered as a stable model. So to check whether your model is good or bad, you have to do cross validation. This is nothing but beta testing in software. You have to repeatedly test the software, right? Same thing here. We are doing the testing of the model repeatedly with the subsets of the same data. Or you can do test, train and test. Now we have forgot, we have a test data also here, right? We have a text data here also. So reg test predict. Reg test predict is equal to, which one we are using? Reg model 2 dot predict big mark test ds. Big mark test ds. I am predicting on the test data. Now reg test predict. These are the values which I got for predicting on the test data. These are the dependent variables. These are logarithmic values, right? These are logarithmic values. So what we have to do? Reg test predict is equal to np.exp reg test predict. Now we will get the reg test predict, the actual values. These are the predicted values of dependent variable in the test data. Remember, we don't have dependent variable in the test data. How we are predicting? Using the trained model. We built a model, reg model 2 on our trained data, and I'm using reg model 2 to predict on test data. Now we got these values. We got these values. Now what I will do is convert this into data frame, pd.data frame, reg test predict dot 2 underscore CSV double quotes reg dot CSV. I am now writing it into a CSV file. I am writing it into a CSV file. All of you write it into a CSV file, predict on the test data and write it into a CSV file. Predict on test data, big mark test data. In the folder path, whatever is given in the top now, this is the path. Maybe big mark says is my path. Check your path. So I will go to hackathon. AV big mark says, so if I say date modified, see, this is the new file which I have written. Reg.csv. Open this, and you also have sample submission.csv. Open that file also. Open the return file reg.csv and also open the sample submission. This is my reg.csv, predicted values. This is my sample submission. Now, in the item outlets, first delete these values. Don't touch the first two columns in the header. From the second row, I will go to my red.csv. Don't copy the 0 on top. From the values, Control Shift down arrow, Control C, and I will paste it in my sample submission file. Control V, Control S. When you are pasting your output into Control C, don't touch the headers. Paste it from the second row. Don't touch the first two columns. Under item outlet says you have to paste. Don't paste from 0. In your CSV file, it will be 0. So that you don't do it. Once I'll come and sort it out. Now, if you go to Analytics Vidya, participate in hackathon. Bigmart says participate, register, solution checker. If you go to solution checker, upload the CSV file, sample submission file, upload it, reg, no, and add solution. See, my competition RMSC is 1231. RMSC on the test data is 1231. So you have to go to solution checker, upload the sample submission file, write whatever is the algorithm name here, small name, no, and then submit. You will get your solution. See, my solution 1231 is what I submitted today. You can see here, my submission today is 1231. My lowest is 1160 or 1160 is my lowest. Yeah. Control C. Now, upload this go to analytics solution checker. What we paste it into the sample submission file. What happened? Analytics is the Bigmart sales. Upload the sample submission file. Go to analytics and upload it. Open the sample submission file also. Don't copy 0. Copy from the first row. Value. Don't copy 0. You have to sample submission file. You copy paste the data. Now, come on. Bigmart sales. Yes. Sample submission of case. So I have not done it. Now open sample submission file. Copying is predicted data into sample submission data. Control C, go back to sample submission file. Control V. Control S. Now upload it into the sample file. Yes, yes. And then close it and upload it. Hackathons. No, hackathons. What are analytics on your side? You will take out? No, you have to. Solution file, sample submission file. paste చేస్తారా sample submission file లో చేయలేదు కదా ఫస్ట్ ఓపెన్ ద predicted file ఇది ఓకే అప్డేట్ ఫైల్ అయితే ప్రింట్ చేసిన ఫైల్ ఉంది కదా 2_csv ఫైల్ ఎక్కడ రాశారు నోట్బుక్ వెళ్ళండి ఓపెన్ చేయండి 2_csv రైట్ చేసి సేవ్ చేయండి Regression. No. Sample submission पर upload चलेगा अपडेट अभी जो बैलेंस में है इसका ही अपलोड करने को पहले sample submission file వెళ్ళలేదు అప్లోడ్ చేసి అప్లోడ్ చేసి sample submission for correct no, I don't know to accept. Okay, it's 4 o'clock. Let's break for 15 minutes. Okay.